Suppose you want to create an airplane in Blender, but not just any airplane, an airplane that could fly. For example, when you're using 3D printing to print your design or something else, or if you just want to be accurate, at some point you will need to import accurate airfoil shapes. And how can you do that in stock Blender? Well, you can either download an image of your airfoil and then just mess around with points to try and approximate the shape, or you can mess with path, but all of this is not very accurate. If, like me, you have used CATIA before, you will certainly remember that option to import random points from Excel, which allowed you to then import the outline of the airfoil. However, it was quite slow as well, and we don't have that possibility in Blender. Otherwise, some other people on the internet have come up with some tutorials on how to import airfoils with DXF or SVG files, but to get those files you first need to generate them, and as if you're used to some aerodynamics tool like Airfoil or AirfoilTools, usually the airfoils are outputted in txt file with just the points, so you would need another program to generate those DXF or SVG files, and that's not very practical. In order to solve that problem, I created the AirfoilTools add-on. So it's an add-on that allows you to either import or generate accurate airfoils in Blender. Let's jump into it. Alright, so first of all, let's install the add-on. So the first step is to navigate to the GitHub page of this project. The link will be in the description. Then you download the zip file. Now go to Blender, go to Edit, Preferences. In Add-ons, choose Install. Now go in your downloads and select the zip file you just downloaded. Select Install Add-on. Once it appears, you can enable it. You have some information here about the version. And once it's enabled, you will find here in the side panel the AirfoilTools menu. So what are you going to see? You have two main panels. The first one here to select which airfoil you want to plot, and the second one, the plotting options. You have several modes to select your airfoils. You can either import it from a file to generate like a 4-digit airfoil or a 5-digit airfoil. The parameters to generate those NACA airfoils, if you're not comfortable with them, I will link the Wikipedia page for those NACA airfoils in the description. But otherwise it's quite simple. You have here the camber settings first, the thickness here, then you have the amount of points that will be used to plot the airfoil. Then this option here, cosine point distribution, if it's enabled, will concentrate more points at the leading edge and trailing edge of the airfoil. I'm going to show you what it means. So with that option selected, you can create the points, generate the airfoil surface. Then I'm going to unselect it, create points, and generate another surface. Now let's see what the difference is. So let's switch to edit mode, and here you see, so the one on top is with the cosine point distribution. You have much more points at the leading and trailing edge, and this allows to prevent this kind of artifact, where the leading edge, which is quite an important aspect of the airfoil, does not have the correct shape. So that's for the cosine point distribution. Then the two next options are to create or clear the points. So create points, it will just take all those parameters and plot the points in a list. Clear points, then if you select that, you just delete that buffer. So now that we saw the NACA 4-digit airfoils, we can have a look at the NACA 5-digit airfoil. You can find here similar kind of parameters, except that the maximum camber is replaced by the design lift coefficient. Again, for those parameters, there will be a link to the Wikipedia page if you're not familiar with those parameters. So yeah, thickness is the same, points is the same, cosine point distribution as well. Here you have one extra parameter for the NACA 5 digits, which is whether you want it reflexed or not. If don't know what a reflex airfoil is, it's basically an airfoil where there is a slightly positive camber near the trailing edge, which is especially useful to make the moment coefficient more positive or reduce it in absolute value, which can be useful for flying wings, for example. But so what does it mean? I can show you an example. So here, create the point, generate the surface, and one without camber. It's very subtle, but you can quite see that the one with the camber, that the reflex airfoil looks a bit bent upwards toward the trailing edge. So it's subtle, but it's there if you want to make flying wings. So yeah, also you might have noticed that for both NACA 5 and 4-digit airfoil, there is the name generation here. So it was the same for NACA 4 digits, and when you create the points and plot the surface, it also renames the surface with the according name in the collection, so that can be useful. The last airfoil generation option is file import. So here you can import a text file from somewhere. If you have, for example, a supercritical airfoil which is not generated, you can import it and generate the surface, so you can have specific airfoils, and the path to your text file is also shown. Talking about the file import, be careful, because so the text files which are supported are compatible with the text files that can be saved from here, airfoil, for example. If you save it and make a text file, that should always work. But if you're going in Airfoil Tools and save in static that format, it should work as well. However, be careful that in that case, if it's not a NACA or NASA airfoil, do delete the header here, because it could raise some errors. If it's NASA or NACA in the title, it should not make a problem. And also always check that the separators here used are a tab and not spaces or other weird things. Okay, the next panel does contain some options for the plotting. So for example, once I create the point, so here I can, of course, the big button to generate the airfoil surface. You have the option to either fill or not fill the airfoil surface. So the difference here is that if it's not checked, it will just plot the outline, which can be useful if you don't want to mess with surfaces, which if you want to solidify it later. And the last option is the chord length. So that's just a multiplier for those points. So for example, if I want to go have chord length of 1, I generate the surface, and it just has a length of 1. If you go to item, dimension X is 1. So now, how to use this add-on the most efficiently? There are two main ways. One to be used if you plan to have a wing with only one airfoil, then you just need to create the point, generate the airfoil surface, tab into edit mode, and extrude it, and you have a very nice wing with one constant and accurate airfoil. If, however, you want to create a wing with where you will have several different airfoils, then you can just generate one first airfoil. Then if you want a thinner airfoil at trailing, for example, create the points, generate the surface, and then here you will have your leading, your root and tip chord. Then you join them together, tab into edit mode, and then I do strongly suggest for you to install the Loop Tools add-on, which comes by default in Blender, and it's very useful. So once you enable that one, you can then have the option to bridge those two surfaces, and then you have a very nice wing with two different airfoils, which can of course then be extended to 3, 4, 5, 10 different airfoils, whatever you want. Be careful, however, if you want to plot a wing with several multiple airfoils, all of them should have the same amount of points and the same distribution, otherwise you will have some artifacts and some errors which you don't want. Alright, So now we have seen the basics on how to use this add-on. I will show you an application on how you can use it efficiently to recreate a wing with accurate airfoil. So for example, if you want to make that very nice XFL one, you can already just hide the fuselage, go to Airfoil Tools. We will take like a 4 digits because it's quite generic for this kind of aircraft. For those aircraft, usually it was quite a thick airfoil, so 15%. You create the point, generate the surface, then you just align it with the YZ plane. Go inside view, align it with the root, then you can tab into edit mode and start extruding. Here the first segment, second segment, scale it down. Then you just apply the dye here a little bit. Then don't forget to apply location, rotation and scale, so you don't have weird artifacts when you bring up the mirror modifier. And there you have it. You have a wing with an accurate airfoil, which then can be used for, if you want to 3D print this airplane, it could actually have the correct aerodynamic parameters as you would have designed it, and it also just looks nicer as you have the nice curves that you would see on real aircraft. To conclude this video, I would like to remind that this is a beta version of the add-on, so more features will come, and don't hesitate to put in the comments or on GitHub what features you would like, what bugs you encounter as well. Some features I was planning to add are mainly perhaps some other options for airfoil importation, perhaps a built-in database for Epler airfoils or NACA supercritical airfoils, and perhaps a selection on which plane the surface would be drawn for the airfoil, so that you don't have to move it around directly. So yeah, don't hesitate to put that in the comments what you would like to see, what doesn't work, what works, and have a good day.